Hey there, science fans! Today we're diving into the exciting world of organic chemistry. Don't worry, it's not as complicated as it sounds. Let's start with hydrocarbons, the superstars of this chemical world. Hydrocarbons are like the Lego bricks of chemistry. They're made up of just two elements, carbon and hydrogen. These little guys are super important because they're the starting point for making tons of things we use every day. Think plastics, fuels, and even medicines. Now, hydrocarbons come in different sizes. Some are small and simple, like methane, the gas we use for cooking. Others are big and complex, like the ones found in crude oil. But here's the thing. Sometimes those big hydrocarbons are too big for what we need. That's where cracking comes in. Imagine trying to build a tiny house out of giant Lego blocks. It wouldn't be easy, right? That's kind of like what it's like to use big hydrocarbons for certain products. We need to break them down into smaller, more manageable pieces. That's where cracking comes in. It's a process where we use heat and special catalysts to split those big hydrocarbon molecules into smaller ones. Think of it like a controlled chemical explosion. Cracking is super important because it gives us the right-sized building blocks for making all sorts of useful stuff. For example, ethene, a small hydrocarbon made from cracking, is used to make plastics and even synthetic rubber. So cracking helps us turn something big and bulky into something much more versatile. Pretty neat, huh? Now let's talk about polymers, those amazing molecules that are all around us. Remember those small hydrocarbons we talked about like ethene? Well, they're the key ingredients for making polymers. Think of polymers like long chains made by connecting lots of small molecules together, kind of like linking paper clips to make a long chain. These chains can be really long and they can be arranged in different ways, giving polymers their unique properties. For example, polyethylene, one of the most common plastics, is made by linking together lots of ethene molecules. It's used to make plastic bags, bottles, and even toys. Another cool example is polystyrene, made from the monomer styrene. It's used to make styrofoam cups, packing peanuts, and even disposable cutlery. Polymers are like the chameleons of the chemical world. They can be molded into different shapes, and they can be soft, hard, flexible, or rigid. This makes them incredibly useful for all sorts of things. Think about it. Polymers are in the clothes we wear, the cars we drive, and even the phones we use. They're used in packaging, construction, medicine, and so much more. The amazing diversity of polymers comes from the different ways we can link those small molecules together and the different types of monomers we use. It's like having an endless box of Lego bricks. Section 5, Plastic Problems. Let's be earth-friendly. But here's the thing about polymers, especially plastics, they can be a bit of a problem for our planet. Because they're so durable, they can take hundreds of years to decompose in landfills. That's why it's super important to recycle plastics whenever possible. Scientists are also working hard to develop eco-friendly polymers that are biodegradable or compostable, meaning they can break down naturally without harming the environment. We can all do our part by reducing our use of single-use plastics, reusing plastic containers, and, of course, recycling. Section 6. Alcohols, not just for drinks. Now let's move on to another important group of organic compounds, alcohols. You might know that ethanol, a type of alcohol, is found in beer and wine. But alcohols are so much more than just beverages. Alcohols are like the hydrocarbons with a twist. They have a special group of atoms called a hydroxyl group, OH, attached to a carbon atom. This hydroxyl group gives alcohols some unique properties. For example, alcohols are good solvents, meaning they can dissolve other substances. That's why isopropyl alcohol is used as a disinfectant. It can dissolve and kill bacteria. Section 7. Carboxylic acids. Phew, that's smelly. Next up, carboxylic acids. These guys are like the sour pusses of the organic world. They have a carboxyl group, CoO, which makes them acidic. You know that pungent smell of vinegar? That's acetic acid, a type of carboxylic acid. And that tangy taste of citrus fruits? That's citric acid, another carboxylic acid. Carboxylic acids are used in all sorts of things, from food preservatives to making soaps and detergents. Section 8. Esters, fruity scents and flavors. Last but not least, let's talk about esters. These compounds are like the perfume masters of the chemical world. They're known for their sweet and fruity smells. Esters are formed when a carboxylic acid reacts with an alcohol. This reaction is like a chemical handshake, creating a new molecule with a unique aroma. For example, the smell of bananas is due to an ester called isoamyl acetate, and the scent of pineapples is from ethyl butanoate. Esters are used in perfumes, flavorings, and even as solvents in nail polish remover. Section 9. Organic chemistry. It's all connected. As you can see, hydrocarbons, alcohols, carboxylic acids, and esters are all interconnected in the amazing web of organic chemistry. They're like different characters in a grand chemical play, each with their unique roles and properties. Understanding these basic building blocks helps us understand the world around us in a whole new way. It's like having a secret decoder ring for the language of molecules. So, next time you encounter a plastic bottle, a squirt of hand sanitizer, or a whiff of perfume, think about the incredible chemistry happening right under your nose. Section 10. Chemistry in our lives, from medicine to materials. Organic chemistry isn't just something you learn in a textbook, it's all around us. It's the science behind the medicines we take, the clothes we wear, the food we eat, and so much more. From developing new life-saving drugs to creating innovative materials, organic chemistry plays a vital role in shaping our world. Section 11. Keep exploring the amazing world of chemistry. So there you have it, a crash course in hydrocarbons, polymers, and organic compounds. I hope you've enjoyed this journey into the fascinating world of molecules. Remember, science is all about asking questions, exploring the unknown, and never losing your sense of wonder. So keep asking questions, keep experimenting, and keep discovering the wonders of chemistry.